Hello everyone, we are out to solve for s in this equation that says 5 raised to the power s times 5 raised to the power s times 5 raised to the power s equals to 60. So if we say solution to boost our confidence, if a is raised to power n multiply a raised to power m, it's okay if we say a is raised to power n plus m. So when you have the operator as a multiplication, you now add their powers. So we're going to say 5 raised to power x plus s plus s in three places equals to 60. Yes. So if we do this very well, it becomes 5 raised to power 3s is equals to 60. Alright, so if I write 5 raised to power 3 equals to 60, it's still the same because if a is raised to power n, raised to power m is still as a raised to power n times m. So if we do this, we're fine. And 5 raised to power 3, that is 125 raised to power s is equal to 60. So from here, we're going to take the log, natural log to both sides, which will become log 125 raised to power s equals to log 60. So, and eventually this will be s log 125 equals to log 60. The reason is when you have log a raised to power s, it's the same thing as log s, the power multiplies the log of a. That's why we transfer the s down so that they can multiply the log. So if we do this, because we're looking for s, we can divide both sides by the coefficient of s, which is log 125, and that becomes x log 125 all over log 125 is equal to log 60 all over log 125. And of course, 125 will cancel out to be left with s, which is exactly what we're looking for, equals to log 60 over log 125. We can consider this to be our final answer, but there's something we can still do to this equation to further simplify it. We remember previously that the 125 was 5 raised to power 3. We can break this in to help us simplify further. And 60, we can derive perfect squares from 60. For example, if we have 60 and we divide through by 2, when 2 divides 60, we can have 30, that's correct. And 2 can still go 2 into 30, that is 15. And at this point, 5 can go and 3 can go. I would prefer 3 because it's smaller than 5. So if I use 3, it will eventually becomes 15 divided by 3, that is 5. And 5 is finally here, 5 into 5, 1. So from there we have, so this will be 2 raised to power 2 times 3 times 5. So in place of 60, we're going to write this so that we can break it further as get it simplified more than this. But the value of s will be more simplified. Alright, so we'll continue from here. So since we have values for 60 and 125, we're going to therefore write s to be equal to log, in place of 60, we are writing 2 raised to the power 2 times 3 times 5, which is correct, all over log. In place of 125, we are going to write 5 raised to power 3. Yes. So from the numerator, we'll end up having log 2 raised to power 2 plus log 3 plus log 5. Because we are given log AB, it's okay if you write it as log A plus log B is the same. That's what we have just transformed the numerator to. And this will eventually become over log 5 raised to power 3. And from what we have done here, we're going to bring down the powers. The 3 will multiply the log, and the 2 multiplying log, and the 3 multiply the log. So it ends up s equals to 2 log 2 plus log 3 plus log 5 all over 3 log 5. So this is where we're going. Since the LCM is common to them, we want to write them each separately. So we'll continue from there. So what I mean is S is equals to 2 log 2 all over 3 log 5 logs log 3 all over log 3 log 5, forgive me, plus log 5 all over 3 log 5 finally. And also this can be written as S equals to 2 over 3 log 2 all over log 5 logs 1 over 3. The coefficient of log 3 there is 1 over 3 log 3 all over log 5 plus 1 over 3 log 5 over log 5. And obviously log 5 will cancel out. And if you want to write the next line, let's take the constant first. S will be equal to 1 over 3 plus 2 over 3 log 2 over log 5 logs 1 all over 3 log 3 over log 5. But if you remember, log A over log B is the same thing as log A base B. So if we employ this here, the equation will take another form. Our S therefore will be equals to 1 over 3 plus 2 over 3 log 2 base 5 plus 1 over 3 log 3 base 5. And this is a multiplied answer for S. But we can prove this to show if we are correct. So let's go into the proof. So to verify, we want to show that the left hand side should be equal to the right hand side. Verify. So the first decision we'll make will be anywhere we have S, we'll put this value that we got. But because of the length, we want to pick one and work on it. So the answer we got will be multiplied by 3. What do I mean? Let's say 5 raised to power 3 is equals to 5. Place of S, write 1 over 3 plus 2 over 3 log 2 raised to base 5 plus 1 over 3 log 3 base 5. And if you do this, this is the same thing as 5 raised to power 1 over 3 times 5 raised to power 2 over 3 log 2 base 5 times 5 raised to power 1 over 3 log 3 base 5. Yes, and this is the same thing as 5 raised to power 1 over 3 times 5 raised to power log 2 raised to power 2 over 3 base 5. The power goes up times 5 raised to power log 3 raised to power 1 over 3 base 5. And if you remember, if log A is raised to power log B base A, our answer from here is equals to B. We are going to do that here. If we look closely, log to base 5 we cancel out, log to base 5 we equally cancel out. So eventually it will become 5 raised to power 1 over 3 times 2 raised to power 2 over 3 times 3 raised to power 1 all over 3. So from here, if we bring the one that has the same power together, 1 over 3, 1 over 3, it will become 5 times 3 raised to power 1 over 3 times 2 raised to power 2 over 3. 5 raised to power s is equals to 5 times 3, 15 raised to power 1 over 3 times 2 raised to power 2 over 3. S 5 raised to power s equals to 15 raised to power 1 over 3 times 2 raised to power 2 odd over 3. Just one part, 5 raised to power s. So what if we do for the 3 part, 5 raised to power s and 3? This value will be multiplied 3 times, which is equal to 15 raised to power 1 over 3 times 2 raised to power 2 over 3 times 15 again raised to power 1 over 3 times 2 raised to power 2 over 3 times the last part 15 raised to power 1 over 3 times 2 raised to power 2 whole over 3. Let's bring all the 15 together to be 15 raised to power 1 over 3 times 15 raised to power 1 over 3 times 15 raised to power 1 over 3 times 2 raised to power 2 over 3 times 2 raised to power 2 all over 3 times 2 raised to power 2 all over 3. And again we can have 15 to the raised to power 1 all over 3 plus 1 all over 3 plus 1 all over 3 times 2 raised to power 2 all over 3 plus 2 all over 3 plus 2 all over 3. So this becomes 15 raised to power. Since the denominator is the same, we can therefore add the numerator, which becomes 3 over 3 times 2 raised to the denominator, which is the LCM, is the same. We can therefore add the numerator, which is equals to 6 all over 3. Yeah. So 3 over 3 ends up being 15 raised to power 1 times 3 here 1, 3 into 6, 2. So this 2 raised to power 2 is equals to 60. 15 times 4 is equals to 60. 15 times 4 is 60. Is equals to 60. So the value we got for s, okay, we have cleaned it, is actually accurate because it satisfies the original equation. It replaces it. So the left hand side is directly equal to the right hand side. Thank you for seeing through to the end.